the distributive property. Now, why is it the best property? Well, there's lots of reasons, but the first one I'm going to say is because while the other properties had one for addition and one for multiplication, this one is both at the same time. The full name of the distributive property is the distributive property of multiplication over addition. What does that mean? It means we are going to distribute multiplication over addition. We're going to take this number on the outside of the parentheses. Notice, right up against parentheses always means multiplication. So A times B. And then we hit an addition, A times C. This is the distributive property. You'll often see me drawing arrows. Draw your own arrows, draw mental arrows. I like real arrows, but mental arrows are fine as well. To each their own. It doesn't have to be in front. This direction, we locate where the multiplication is. It's over here at the end. There are two terms inside the parentheses, so we're going to swing it twice, one to every term in there. This is A times C plus B times C. Now, you can also say C times B plus C times A. You can also say C times A plus C times B. Why? Because of various forms of the associative property and commutative property. They all mean the same thing as long as you're swinging it around. So let's go ahead and apply the distributive property to some examples. We would read this example as 4 times the quantity 2x plus 5. Applying the distributive property, there are two terms inside. Multiply times each. 4 times 2x plus 4 times 5. 4 times 2x is going to be 8x. Why? Because of that property that says we can multiply the 4 and the 2 together before multiplying by x. Because 4 times 2x is 4 times 2 times x. And we can pick any 2 to do first. We can't do anything to the 2 times x, but we can do the 4 times 2. Plus 4 times 5 is 20. So our answer is 8x plus 20. And you don't have to write it out like that. The distributive property is a very quick thing that you can do mentally. So you see this, 4 times 2x is 8x, 4 times 5 is 20. A plus there, so a plus there. Now, I did say you should always pay attention to your signs. Here, everything was positive. You can go through without any issues when everything is all plus. But let's say we had -3 times the quantity A plus 2B minus 5C. Okay, so the coefficient -3 is going to be multiplied by every coefficient here as part of multiplying the entire -3 by each term. Remember, the sign in front is a part of the term. So when we get to this third part, we need to multiply the entire -3 times the entire -5C. And what happens when we multiply a negative times a negative? Well, it's going to turn into a positive. Let's do this work. -3 times A is -3A. -3 times positive 2B, negative times positive is negative. 3 times 2 is 6, and we have a B. -3 times 2B is -6B. -3 times -5C is positive 15C. Okay. We can't take this answer any further. Let's talk a bit more about why we can't take this answer any further. It's about the idea of like terms. This would be an example of two like terms. -8x and 3x. The reason they're like terms is because they have the same variable piece raised to the same power. So -8x and 3x squared, these would not be like terms. They both have x, but they're not to the same power. An x with no exponent is an x to the first power. x to the first power, x to the second power, two different powers, which means we can't combine them in any way. But negative 8x and 3x, if we wanted to add these together, we absolutely could. And we would get some number of x's. That number of x's is going to be what we get when we add the coefficients. Negative 8 plus 3 is negative 5. So negative 8x plus 3x is negative 5x. It's okay if you want to think about the variables as things. If I have negative 8 things and I add 3 things, then I have negative 5 things left. It makes more sense when you're just talking positive numbers. 2 things plus 5 things is 7 things. In this case, the things are y's. So that expression we had that had an A term, a B term, and a C term, since the variable parts were different, we could not add them. Okay. Now we're going to go ahead and combine these last couple of skills. We're going to use the distributive property, and we're going to combine like terms. This is one of the major skills in algebra. This is something that the better you are at this, the better you're going to be at everything else, because this is a step in many things going forward. The first step in simplifying any expression is to clear parentheses. And the way you clear parentheses in any problem is by using the distributive property. So let's take a look here. You might be tempted to do 4 minus 3 first. And if, please don't write this, if you do 4 minus 3 first, that would be a problem with order of operations. And an order of operations issue is devastating. Order of operations says we would do multiplication before subtraction. This is subtraction, but we have something right next to a parenthesis. That means multiplication, and multiplication comes first. If you're saying, wait a minute, P comes first, PEMDAS. Please excuse my dear Aunt Sally, we have parentheses. Is that why we do this? Well, it's interesting that it would work out that way, but that P has nothing to do with the fact that we do this multiplication first. What this P means is work inside of the parentheses. And if we look inside the parentheses, we have 2 times x. And if 2 times x were a number, we would do that first. But we can't simplify 2 times x any more than it already is. We have 2x minus 8. But these aren't like terms, so we can't actually subtract them. It wouldn't be negative 6 anything. Not negative 6x, not negative 6. 2x, 8 with no x, we can't minus them. Since there's nothing we can do inside of the parentheses, then we would move on. There's no exponents. So then multiplication and division from left to right. There's our multiplication. So this is what we do first. How do we handle a number next to a parenthesis? Distributive property. What are we distributing? The negative has to come with it. And since there's two terms, we're going to end up with two swings with the distributive property. Everything that's unrelated can just get copied down. That 4 is just going to come down to the next line. -3 times positive 2x. Negative times positive is negative 6x. -3 times -8. Sign in front always goes with it. Negative times negative is positive. 3 times 8 is 24. Don't swing -3 times the -1. When the parenthesis closes, the distributive property is done. So just carry it down. We have about 10 minutes left, just under. Now, the distributive property is done. All that's left is addition and subtraction. There's this little piece of multiplication here, 6 times x, but 6 times x is 6x. That's going to stay there. None of the other terms have an x. This is the only x term. So that -6x is going to stay by itself. What do we have here? This is a +4. It's not 4 minus anything. That minus is with the 6x. It's moved down. It's done on its own. Pretend that's not there at all. That is a 4 plus 24. 4 plus 24 is 28. What kind of 28? Positive or negative? Positive 28. I need you all to know, carry down the -1. I'm gonna keep with it too because it amused me. Normally, we'd be in class. I would say, "What kind of 28?" And maybe one or two of you would say positive. I pictured the Blues Clues kids just go positive. So from now on, you guys are the Blues Clues kids to me. Isn't that wonderful? Finishing this off, again, keep the -6x. Positive 28 minus 1, that would be positive 27. So -6x plus 27. Question you might have right now. The -6x, do the x's have to come first? Good question. Let's say instead of putting the x's first, we just went, since this 4 was the first number, let's look for all of the no x terms. So that's +4 plus 24 would be +28, -1 would be +27. And then what's left over? Minus 6x. So you could also have 27 minus 6x as the answer. They're exactly the same. Why? Well, 27 minus 6x is the same as 27 plus minus 6x, because subtraction is adding the opposite. What can we do when we have two things with a plus? We can switch them around the plus sign. So the negative 6x plus 27. It's how we switch it. It wouldn't be 6x minus 27. It would be negative 6x plus 27. So either form of the answer is okay. Even if you got it, you don't have to do all the work to get it that direction. It depends on how you want to write it. If you did the work and you got 27 minus 6x and you like having your x's first, then feel free to write it this way. Just make sure you do it correctly. Make sure that you keep the negative with the 6x and realize that here you have a plus 27. I want to go over some words that you might see. Sum, difference, product, quotient. Sum means plus. Difference means minus. Product means multiply. Quotient means divide. When you see of on its own, that means multiply. But when you see sum of, difference of, product of, quotient of, that's giving you order. So these sum of, difference of will always be followed by an and. And the two things on either side of the and are the two things in order that are added, subtracted, multiplied, and divided. The sum of 8 and a number. An expression like this can be converted to a mathematical expression. Direct translation, I had said the sum of indicates an addition problem, and that the order would come from around the word and. So 8 and a number. And in this case, an unknown number would be represented by X or N. If it doesn't specifically tell you what letter to use, you're free to pick any letter at all. And I was explaining that the point of these algebraic expressions is that they can model real life situations, and we call those algebraic models. I'd like to pay special attention here to the subtraction wording, okay? think of the regular expression 4 minus 3. Okay, 4 minus 3 could be the difference of 4 and 3. But it could also be, if you have 4 and take away 3 from it, you would be subtracting 3 from 4. You wouldn't say that this is subtracting 4 from 3. You're starting with 4 and you are subtracting 3 from it. 4 take away 3 is 1. Subtract 3 from 4. Or maybe three less than 4. So these are all different ways of saying 4 minus 3. If we saw any of these and we wanted to translate it into numbers, it would be 4 minus 3. Algebra is going to replace one of our known numbers with unknown numbers. So in this case, instead of the difference of 4 and 3, this would be the difference of x and 3, or the difference of, since x is a number, the difference of a number and 3. Subtract 3 from x, subtract 3 from a number. Okay. The reason I'm pointing this out and paying special attention to it is addition. If you happen to get the order wrong, it doesn't matter. Remember, we can add in any order we want. But subtraction, the order does matter. If we get the order wrong, we literally get the opposite. So if you had to translate from words, from words into math, subtract 13 from a number, please just be sure you do not write 13 minus x, okay? Subtracting from something, you're starting with that thing and subtracting 13. So x minus 13, n minus 13, whatever. The beauty of algebra, the magic, the reason why we do it, comes from when we connect expressions to make equations, and equations have equal signs. The sentence form of an equal sign is the word is. When you say something is something, you're saying it is equal to something. So let's say you were building a fence for some reason, and you needed to make your fence 200 yards. And your fence is rectangular, and you want the long side to be twice as long as the short side. So using algebra, and don't worry too much about this, I'm just introducing the concept. These sort of word problems, that's not this lecture. That's down the road a little bit. But let's say you wanted your long side to be twice as long as your short side. Well, that means if your short side is whatever, x, your long side would be twice that. Twice a number means 2 times a number. And all around, you want it to be 200 yards. Well, that means there's another x over here, and there's a 2x there. If you want to add up all the sides, that's 2x plus 2x plus x. And that expression can simplify. We can combine the like terms. If it's just a regular x, that's like having a 1x. That is like having a 1x. 3, 4, 5, 6. So 6x would represent the distance around this rectangle. If you're building this rectangle fence and you want the fence to be 200 yards, then this is 200 yards. And see, then if you could solve for x, you would know how long you have to make this, and then you can plug in for x and you would know how long to make that. So the whole point of knowing how to solve equations is so that in real life, if you happen to be doing something that can be modeled by an equation, it makes the work easier to get this exact answer than it would be to be out there with your fence supplies and you build the fence. And you're thinking maybe this might work, and then you run out of fence. You got to tear the whole thing down and start over. I know that's probably not how fence building works, but you get my point. It's easier to know exactly what your measurements are going to be and to figure it out than to guess and check. Algebra is about the method that we use to get our answers. It's not about the answer itself. Anyone can guess and check. That's not doing math. So the type of equation we're going to talk about today is specifically a linear equation. And these equations are specifically going to have only one variable in them. So what it means to be linear is that the graph of the equation would express as a line. Linear means line. Linear equations are not going to have x squareds. They're not going to have x cubes. They're not going to have square roots. They're just going to have the variable raised to the first power. And anything to the first power is itself. So just like a 1x, we don't write the 1x to the first. We don't write the exponent of 1. So linear means line, means the variable is to only the first power. Linear equation in one variable means that if our variable is x, then we're only going to have x's. There won't be x's, y's, z's, all in the equation. And I said before, equations have equal signs. You can see EQUA. Equal is part of the word equation. That means that the left side is equal, exactly the same as the right side. Picture the scales of justice, that statue of the lady with the blindfold on that's holding out the old-fashioned scale. For those scales to be balanced means that there's the same weight on each side. If you were to add weight to one side, the scales are not balanced anymore. Too much to the other side, not balanced the other way. The only way to keep them equal is once they are equal, whatever you do to one side, you have to do the exact same to the other to keep it balanced. For instance, 1 plus 2 is equal to 3. We don't see the number 3 here, but we know that 1 plus 2 is 3, and we know that 3 equals 3. So this equation is true. If we said x plus 2 equals 3, then there is only one possible thing x could be. X has to equal 1 because only 1 plus 2 equals 3. But that's not algebra. Like I said, anyone can try to figure out what's in there, check it, and be right that way. That's not algebra. Algebra is about a process. Whatever we do on one side, we have to do to the other. And we do that by doing the opposite. We undo steps so that we get the x, the variable, by itself. So how would we solve something like this? We need to get the x by itself, which means we need to undo adding 2. We're going to undo adding 2 by doing the opposite of adding, subtracting, minus 2. But if we subtract 2 from the left, it's not balanced anymore. Think of the scales. So if we subtract 2 from the left, we have to subtract 2 from the right. The reason we subtract 2, the reason we do the opposite is because it cancels out. Plus 2 minus 2 is 0. On the other side, 3 minus 2 is 1. So we're just left with the x on the left. X equals 1. Same answer we got by looking at it, but there's going to be plenty of equations that you can't look at and figure out what the answer is. It gets a lot more complicated than 1 plus 2. I will tell you that. So this is the addition property of equality. In English words, the addition property of equality, if we have two things that are equal, we can add the same thing to both sides and it will still be equal. And since subtraction is just addition in disguise, subtraction falls under the addition property of equality. Just like we can add the same thing to both sides, we can subtract the same thing from both sides. So let's say we have 12 equals y plus 16. 12 equals y plus 16. We want to get the y by itself. We need to get rid of adding 16. So we are going to subtract 16 from both sides. On this side, they just cancel each other out, leaving us with just y. On the other side, 12 minus 16 is negative 4. So negative 4 equals y. you can check your answer. You can go, if that's true, then I can plug -4 in. -4 plus 16 is indeed +12. So it checks. Our answer is guaranteed correct. -8 equals t plus 13. Okay, here we want to get the t by itself, which means we need to undo adding 13. We are going to subtract 13 from both sides. Whatever we do on one side, we have to do to the other. 13 minus 13 cancels out, leaves us with just t on the right. -8 minus 13, that's going to be -21. Again, you can check your answer. If that's true, that means -8 equals -21 plus 13. -21 plus 13 is indeed -8. The answer checks. T equals -21, guaranteed correct. And again, there's no difference between writing it this way with the t on the right and writing it this way with the t on the left. Equals means equals. The left side is the same as the right side, so it does not matter what order things are on. The t can be the left, the t can be the right. The -21 can be the left, the -21 can be the right. It does not matter. The multiplication property of equality, similar to the addition one. The addition one said we can add the same thing to both sides and keep things equal. Multiplication one says we can multiply both sides by the same thing and keep it equal. And where we go with multiplication, we can go with division, dividing both sides by the same thing. If it's true that A equals B, then we can multiply both sides by the same thing. We can divide both sides by the same thing. Just like we were able to add and subtract. When would we need to multiply and divide both sides by the same number? Well, just like we subtracted when we wanted to get rid of adding and added when we wanted to get rid of subtracting, we are going to multiply to get rid of dividing, and we are going to divide to get rid of multiplying. Three x equals 12. 3 times x equals 12. We want to get the x by itself. The x is currently being multiplied by 3. We undo multiplying with dividing. So divide the left by 3. But Whatever we do to the left, we have to do to the right. So divide the right by 3. Here, this cancels each other out. Just leaves x on the left, and then on the right, 12 divided by 3 is 4. We can check the answer. If that's true, it means that 3 times 4 is 12, and yes, 12 is 12. This checks. X equals positive 4 would be the correct answer. Let's take this a step farther. 4 equals W over 2.2. Okay, now here we want to get the W by itself. The W is currently being divided by 2.2. We undo division with multiplication. So we are multiplying both sides by 2.2. So 2.2 times 4, 2.2 times this division problem. Looks like a fraction because fractions are division problems. The 2.2's cancel out on the right, just leaving us with our W. On the left, we need 2.2 times 4, and that's going to give us 8.8. W equals 8.8. So a question you might have at this point: how do I know when to add, when to subtract, when to multiply, when to divide? They're all the same. They look different, but they're all the same. You just have to realize what we're doing. You want to get the variable by itself. What's happening to the variable? Do the opposite. So the reason we're adding in a problem where we add is because we are getting rid of subtracting, because subtracting is the opposite of adding. Adding is what's happening to the variable. We want to get the variable by itself. Okay. Before we do anything else, let's do something quick and easy like this. The opposite of A equals -2. You might want to say negative A, but this is really the opposite of A, because A might already be negative. You never know. So the opposite of A equals -2. Well, here we're going to divide both sides by -1 because negative a, recall, is actually -1a, which means -1 times a. What's happening to the variable? It's being multiplied by -1. Do the opposite. Divide by -1. That's going to just leave us with a. Because if you imagine that's a -1, those negative ones cancel. -2 divided by -1. Negative divided by negative is positive. 2 divided by 1 is 2. So a equals 2. That's another one of those. Well, that seemed obvious. If the opposite of a is -2, a must be 2. Absolutely. This is why. So you can take the opposite of both sides in a situation like this. Since we know that's going to work out, if you get it all the way down to the opposite of the variable is whatever, you can just go, oh, well, I'll just take the opposite then. Take the opposite of both sides, get your answer. The opposite of x equals 6. Well, take the opposite of both sides. X equals -6. See, this is why I said saying negative x isn't a great idea, because x is already -6. The opposite of x would be +6. The opposite of x is +6. Let's do another one like this one we had before. Here, 5 equals t divided by 16. We want to get the variable by itself. What is happening to the variable? It is being divided by 16. Do the opposite. Times 16 to both sides. Times 16. Cancels. Leaves t on the right. 16 times 5 is 80. This is going to be a little more complicated than they have been. -3/5 p equals 4/15. -3/5 p equals +4/15. So I want you to take a second and think about what the answers to my out loud questions would be. You want to get the variable by itself. What is currently happening to the variable? Do the opposite. So hopefully the answer you gave to what is happening to the variable is It's being multiplied by -3/5. This is -3/5 times P. So do the opposite would be divide by -3/5. So this is why it is important to know how to multiply, divide, add, and subtract fractions without using a calculator. Because if you know the rules, you will know the steps to solving. We want to divide by -3/5. Remember, when we divide by a fraction, we multiply by the reciprocal. Dividing by -3/5 is the same as multiplying by whatever that flipped upside down is. Multiplying by -5/3. Notice the reciprocal doesn't change the fact that it's negative. So we need to divide by divide by -3/5, which is multiplying by -5/3. So how about that? If we multiply this side by -5/3, negative times negative is positive. So there's no more sign there. The 5s cancel and the 3s cancel, just leaving us with P. So P is going to be whatever 4/5 times -5/3 is. Positive times negative is going to be negative. If we cancel, (5) and 15 can both be divided by 3. 5 divided by, can both be divided by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. Positive times negative is negative. 4 times 1 is 4. 3 times 3 is 9. P equals -4/9. Now that was canceling. If I do this without canceling, (4 times 5 is 20. 15 times 3 is 45. We can reduce. 20 and 45 are both divisible by 5. 20 divided by 5 is 4. 45 divided by 5 is 9. So it's important to be able to work with fractions in order to solve equations that might have fractions in them. Let's do another like this, make sure we know what's going on. -6/5 y equals -3/5. We want to get the y by itself. What is happening to y? It is being multiplied by -6/5. So we want to do the opposite. We want to divide by -6/5. And dividing by -6/5 is multiplying by the reciprocal. Reciprocal doesn't change the fact it's negative, but we flip the fraction, 5/6. Make sure we multiply both sides by -5/6. On the left, 5's cancel, 6 cancels. Negative times negative is positive. So we're just left with the y. On this side, again, negative times negative is positive. The 5's cancel. So we're just left with 3/6, which is 1/2. Okay. So we've done problems that get rid of addition with subtraction. We've done problems that get rid of subtraction with addition. We've done problems that get rid of multiplication with division and division with multiplication. We've even gotten rid of multiplying fractions with multiplying by their reciprocal, or dividing fractions.